My name is Suraj, and I'm a partner engineer at Meta. Today, I'm joined by my colleague Hamid Nazari, who is a ML engineer working on Llama and PyTorch. He's also one of the authors of the Llama recipes repository. Welcome, Hamid.
Thanks, Suraj. Thanks for having me here.
So, Hamid, newer language models are getting better at following instructions, and couple that with new techniques for prompt engineering, like using tree of thought reasoning or chain of thought. It seems like fine tuning might not be as relevant or as important or as critical a method now to adapt language models. What are your thoughts about that?
With the rise of these new prompting techniques that can basically help to extract more nuanced and logical reasoning from the model, fine tuning is still, I believe, remains very valuable, especially when we talk about adapting these pre-trained models to specific domains or tasks. So I want to just note that prompting only can actually guide the model responses in real time. And when you're talking about fine-tuning led us actually to fundamentally reshape the model behavior to a specific application, making it basically more accurate, efficient, and tailored toward the nuances of that task. And think about long run. This could save a lot of cost actually, especially to avoid very long prompts like what we do in few shot examples. So this could be super helpful there, and I believe alongside with all the new prompting techniques, still we are gonna need fine tuning in specific domains.
For fine tuning, so you have a pre-trained model, and then you have some very specific domain related data that you want the model to adapt to, right? And getting the pre-trained model is easy because Llama is open source. But how do you go about like collecting and curating a data set that is very appropriate to the domain that you want the model to be fine-tuned for?
Yeah, collecting and curating these data sets are pretty labor intensive and like very expensive. And so we need to always ensure that our data sets are diverse and representative of the task in hand. So we need to really think through when we are collecting the data and labeling them that this is a representative of your product and how people are going to use your product, basically. And data could come from a variety of resources, basically. Could be like from publicly available data set, scraping web or your proprietary data. Or even sometimes you can see like now we have these user-generated contents on like, different resources that we could use to develop this data. But always we need to kind of watch out for data quality, diversity, and privacy. So these are the main concerns that we really need to look for. But again, altogether, it's a very labor-intensive and pretty expensive process.
Right. And really trying to identify, search, and then retrieve that data from the wild is intensive. And I guess that's where the whole talk about synthetic data generation comes in, right? Where we are using very large and very capable language models to create or generate representative data samples that can potentially replace real world data samples.
When we released Llama 405B, Llama 3.1 405B, that was one of the main use cases for that model. It's a pretty large model, hard to deploy it in production for daily usage. But synthetic data generation is one of the main use cases for these very large models. And this could be super helpful when you are talking about domains that obtaining like a large, high quality data set is very challenging, merely due to the cost, privacy concerns, or simply lack of, available data. And what we are seeing is like this is becoming more and more part of the pipelines for model post-training, especially during the alignment. So if you look at like Llama 3.1 paper, We have actually a very great section elaborating on this topic, how we actually use synthetic data sets, synthetic data basically in the mix for our model alignment. But as you mentioned, these models could, uh, basically be useful in different ways, in a sense that, like, yes, we could do synthetic data gen, but at the same time, we could use them to extract training data from existing domain-specific documents, so they could act as your laborer, basically, to kind of generate that training data for you. And beyond that, we can actually use, and we are using these large models to distill knowledge from them for the smaller models, which those smaller models are much more efficient and easier to deploy in production. So, yes, we mainly use them for synthetic data gen and distillation of the knowledge from them.
Okay, I see the two angles that basically the 4 or 5 billion, or the largest llama that we have, enables. One being where you create new data samples using the language model, and the other being using the language model, the 405B, as a teacher to teach smaller models to imitate it, to replicate it, to generate outputs which would be very similar or very resemblance to the larger and more capable model. And Hamid, taking a step back, you mentioned it briefly, but can you share a little more about, like, what does synthetic data, what does it mean? Like, what are some examples of that? Is it like you give it a whole bunch of documents? So you give 405B a bunch of text, and then you ask it to derive questions and answers pertaining to a specific task, and 405B can just magically generate all of that training data for you?
So there are different ways that you can leverage these large models to actually generate synthetic data. So one of them is what you mentioned, basically using the existing corpora and basically trying to use that model to generate uh, question answer type of synthetic data for you based on your existing document. But the other way, which is even more common, is like when you have different tasks in hand and you have example of those tasks, and you can actually use those instructions to ask these large models to create similar training examples for you. So this is basically using LLMs to generate data based on the task in hand. These are the two common ways that we are using to generate data with these large models. But again, these are like, as these are synthetic data, and these are like generated by these large models. So we need to be extra careful about quality control here and make sure that we have processes in place to watch out for any inaccuracies and hallucinations.
Right. Yeah, it always goes back to that classic trade-off where the language model can be so capable and so spontaneous in its generations, but then you also have to know where to draw those lines and how do you rein in the model so that the quality is ensured. And let's talk about that a little. Like, I mean, already evaluating the quality of real-world data sets is pretty difficult. How does that look like when we are talking about LLM-generated synthetic data?
There are many different techniques really to do that. So some of them, like, really, when you think about it, you can compare it to the real data, like looking at some of the key statistical properties of the synthetic data gen, looking for similarities between like distributions, correlations, or things like variances uh, against your real data sample that you might have. And making sure that those metrics kind of, or those synthetic generated data kind of closely mirror the aspect of the real data. Also, the other ways you could always like evaluate your fine-tuned models on these synthetic data uh, on your downstream tasks. Along with, always we could have human in loop and using techniques like, bias audits and fairness metrics kind of to help ensure that our synthetic data doesn't reinforce any harmful stereotypes or lead to any biased model predictions. um, Generally, like improving synthetic data, and basically thinking about the data quality is an ongoing process. So it's important to like having a feedback loop in place that you can iteratively improve the fidelity and quality of this generated data.
Yeah, I think one benefit that we have with synthetic data is that, like you mentioned, the quality, the feedback loop. You can have a human identify like misses or discrepancies in the generated data, and if packed in the instructions itself, maybe the model is able to fix those issues and fix those gaps and do another run where there are less of those biases visible. I mean that is a potential benefit of using LLMs for generating data, right?
Exactly. So it can make it much more cost efficient in terms of like, and controlling the quality of the data. So it is much easier to modify those synthetically generated data compared to if you wanted to really collect it in traditional ways. So it can save you a ton of tasks and give you a lot more control.
Right. So I guess what I'm hearing is that you still tend to use the traditional techniques to evaluate and measure any discrepancies, any biases, any inaccuracies. But then with synthetic data, you have the extra benefit of being able to rectify those issues in the next run when you specify to the model to take care. Hey, ensure that your generated samples don't have these biases or these mistakes.
Exactly.
I've heard the term groundedness. I mean, all of us have in the last year or so. And I feel like synthetic data also enables us to ensure that the data sets are going to be relevant, or it can be anchored into some real world facts and real world truths. Can you tell us a little about that? Like, what are some techniques over here, or how would you approach ensuring groundedness in the synthetic data?
Sure. I mean, as you mentioned, like groundness really refers to the extent which like the generated data is grounded in the reality. So, in other words, how well these synthetic data actually reflect the real world. So, we use techniques like fact checking and kind of entity disambiguation to ensure like our synthetic data is grounded and accurate. And like methods like RAG or cross referencing with knowledge bases or having human in loops, they could be very helpful here. But overall, we need to always look out for these groundness, because if we don't uh, if we don't pay enough attention or invest in these kind of fact checking, we can end up having like models that could hallucinate a lot, and it's not going to really
Mhm.
reflect the real world data.
It's almost like a reinforcing feedback loop, right? Because once a model generates inaccurate data, misinformation, and then you use that data to train the model again or train another model, it's going to perpetuate these errors, and it's going to probably magnify in magnitude downstream. And that actually reminds me of some research that I had read about model collapse, where training an LLM on LLM generated data can degrade its quality of outputs and degrade its predictions. Uh, how do you ensure that something like this doesn't happen? Because I think like model collapse is broader than just what we are speaking about here, right?
Generally, like there are some issues that can lead to model collapse with synthetic data, where kind of the model can start to overestimate like the probable events and underestimate the improbable but important events. And like sometimes outputs become increasingly more homogeneous, sorry, and less diverse. And the models
Mhm.
gradually forget less common but still important kind of and significant aspects of the original data. And those kind of errors and inaccuracies compound over time and like different generations. So there has been research, as you mentioned, that shows mostly these kind of model collapse happens when we kind of threw away all the original data and only rely on the synthetic data. Whereas if you use them in a mix of original data and the synthetic data, that could be a healthy balance that could actually help you to boost the performance of your model and avoid model collapse.
I see. So it's almost like it's kind of data drift because the distribution of the training data is changing over time and could potentially skew it away from being grounded in real world facts. So one way to mitigate this is to use a good mix of real world data and then synthetic data, which you have ensured matches in distribution and in other properties with real world data.
Yes, and if you look at like some of the uh, just technical reports on the recent LLMs, including Llama 3.1, you can see actually how we have used synthetic data in a mix for our model alignment. And in other reports, you could also see like how people are using it like in a mix with their original data when you want to extend the context length of your model. So those are the places that we are seeing more and more these being helpful, which they have been used in a mix with the original data.
So what you're basically saying is that the ideal way or currently the optimal way to use synthetic data is to augment existing data sets, to use it in the right mix, in the right proportions with real world data. And this increases the number of data samples that your model has to train on in a much more cost efficient way, and also giving you the flexibility to fix any errors, gives you the flexibility to modify any, it gives you the flexibility to update or edit any of the data samples that you have and sort of lean the model towards a direction that you want it to take.
That's right. Yeah.
Hamid, the second approach that you mentioned, or second family of approaches that you mentioned, outside of synthetic data gen, where the 405B model plays a very important role, is in distillation. And distillation essentially means you're taking knowledge from a larger model and you're sort of transferring that knowledge into a smaller model, hence distilled. And it has a lot of benefits because, a smaller model is cheaper to train, cheaper to run. But tell us a little about this.
We have had distillation around for a while, but this is now picking up again. So giving this like very large models. And today, I believe we are dealing with two major distillation streams. One of them is like SDG or synthetic data generated, basically kind of fine tuning. Or we are dealing with the classic, teacher student distillation model, where in the first one, basically, we are trying to use the synthetic data generated from these larger models to fine tune a pre-trained, a smaller model and kind of transfer the knowledge from those big models into these smaller and more efficient models. Whereas in the classic way, teacher students, we want to mimic the behavior of these larger models in a different way. And we put both of them in training mode, and we are using like the teacher model logits or sometimes soft labels, or it's less common, but you can also try to make your student model mimic the intermediate layers of the teacher model. So there are different ways how you can actually do this, and this is like still an open area of research. But there are like variations as well that you can do pruning when you are doing this distillation, and you can iteratively prune your student model, and where your basically neurons or layers are having less contributions to the model performance, so you could prune those layers or neurons to reduce the size and improve the efficiency. Uh, but overall, this is very experimental, and you need to come up with a good framework to make sure that you're not going to lose on the model performance here.
It almost sounds like in SDG, you're sort of the student model is learning the facts as given by the teacher model, but in the classic distillation method or the intermediate layer learning, it's almost like the student model is learning to learn from the teacher. It's by trying to imitate how its activation, how the intermediate activations are generated, and perhaps even the gradients, right? It's trying to see how what gradients or what changes or what errors are being propagated through the weights, and then trying to imitate that. Uh, Hamid, I'm curious. Have you seen any successful real life applications of these techniques? Because it sounds like to me that these might be more attuned to domain specific learning rather than a generalized learning. So, for example, a student model is going to do better when the distillation is scoped to a particular domain or a limited space rather than uh, rather than a very broad space of topics and distribution.
I believe both of them can happen, and like there are like recent articles coming from NVIDIA, I guess, that you could see basically how they have improved the overall performance of a model with general metrics and benchmarks that we usually measure. Uh, when they have distilled using teacher-student kind of paradigm. But I agree that a lot of use cases goes back to more domain specific data where it could be super helpful. But both of them, I guess, coexist, and we usually try to favor the latter, basically looking at like more domain specific data.
Especially because the target model is a smaller model and you don't want to overload it with all the information about every single thing out there in the world.
Yes, exactly. So yeah, I mean, if your 70B model or I don't know, like a larger model is actually working very well in a specific domain for you. So chances that you can distill that knowledge into a smaller model, and where you care more about those tasks, let's say that we are talking about reasoning or math, and then over there you could have a smaller model which is much more efficient uh, in that area, and it might not be like exactly what you need in as an overall in as a general domain. So this is more geared toward the specific domains, I would say.
Right, right. And a lot of applications, LLM powered applications might be very geared towards specific domains, and it would be overkill to be deploying and running a very large model that knows a lot about a lot. And so clearly this is cheaper. You are using synthetic data, which itself is going to reduce your costs of getting any data to adapt a smaller model. And secondly, you are using a smaller model. So not only is training going to be cheaper, your long run costs of deploying it for inference is also going to be much lesser than using a larger model. So, I mean, it seems like these techniques are still very much experimental. Like we're still trying to understand, what is the best way to approach this family of distillation techniques. We're still trying to establish the best practices here. And so because of that, your mileage might vary depending on where you're deploying these techniques for. And it's possible that the smaller student models accuracy might drop below your required thresholds. But that being said, there is a very clear benefit over here because not only are you training a smaller model, you're also going to be utilizing a smaller model in the long run, which reduces your inference costs. And essentially, with smaller models, like there's other benefits as well, right? Like there's lesser carbon footprints. There's more specialization possible over here.
I believe distillation is one aspect that you mentioned, and at the same time, like synthetic data generation could bring significant cost savings, and it can basically reduce, your data collection costs, accelerate development cycles, which is actually a huge cost in many of our big companies, and provides basically scalability and flexibility across different regions and languages where it's harder to actually collect those data. And at the same time, it could also significantly reduce the ethical and regulatory compliance costs because in many cases, you're dealing with domains that there is a sensitivity in collecting data over there, like think of healthcare, finance, and those domains that it is very hard actually to collect any data, and you have to have compliance with many regulations and different considerations, which are even different in different countries and regions. So I believe using synthetic data generation can actually address many of these issues, and it would be much easier to control and save the cost over there.
Oh yeah, that's a good point. Like healthcare already does use synthetic EHR data, and now perhaps we can generate that synthetic data with even more fidelity with the LLMs.
That could be super beneficial. Yeah.
Well, Hamid, thank you for sharing your insights with us. Before we leave, I do want one more insight from you. So it seems like the industry is trending towards using smaller models and having more specialized models for LLM powered applications. What are your thoughts on this trend?
These LLMs are not easy to deploy in many different scenarios, especially when we are talking about on-device stories. And these SLMs or smaller language models, they are very well fitted for scenarios where they can provide better efficiency in terms of like faster inference, easier deployment. And given that we have these larger models and we can use those larger models to distill knowledge into these smaller mini experts. That could be the path that unlock a lot of potentials in AI applications going into different IoT devices, and basically it can live as assistants and automate different tasks across different devices that we are using on our day-to-day basically on our daily life, and like dealing with day-to-day devices on phones and like tablets and laptops. So this could be super helpful.
Like having a small factor actually allows it to be literally embedded in our daily lives.
Yeah, I think like more of a personal assistance is just coming like even in wearables. So yeah.
What I really like about this is that the overall footprint is going to be less, and it's going to be much more efficient, much more friendly to the environment to start deploying and running these. I mean, these are pretty power hungry technologies. So the fact that we are able to reduce that is very promising. It's a very promising future. And in fact, more poetically, I really like the whole circle of life angle going on over here, that you have to build really large, very humongous, massive experts like the 405B model to eventually kickstart the growth of smaller and better specialized mini LLMs.
Exactly. Yeah. We are kind of going to the birth era again, like where we had smaller sizes models, but they were just encoders. So these LLMs are way more capable, and like having those teacher models are gonna augment their performance a lot.
All right. Thank you so much, Hamid, for joining us today.
Awesome. No, thank you for having me. So hope to talk to you soon.